With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, let's start the question. Among the following, correct statement is. So we would be going through each and every statement and then discussing it there itself and hence predicting it whether it is true or false. Yeah. So here goes the first statement. The soles of the metal sulfides are lyophilic. Now, the very first case. Which are the soles of metal sulfides? Can we have any examples? Yes, of course. We can have examples like arsenic sulfide. This is one of the best examples which we have in our reference books also. Yes. So we have metallic sulfides like arsenic sulfide, or we could have any other metallic salts also like FeOH twice, that's iron hydroxide. Yes. So metal sulfide salts are not lyophilic. They are lyophobic in nature. Okay. So that means they have a fear, or otherwise they do not have an affinity towards the solvent. So such lyophobic salts are the ones in which the colloidal system would be containing the particles of the dispersed phase, where they would be having a very little or no interaction with the dispersion medium. Yes, little or no interaction with the dispersion medium. In short, with the solvent. Yeah. The metallic sulfide particles would be the dispersed phase particles. Yes, I hope you understood that. Yeah. So the first statement is absolutely wrong. The soles of the metal sulfides would be lyophobic. Yes. Now let us go in for the second statement. The second statement says that the Brownian movement is more pronounced for smaller particles than for bigger ones. Okay, fine. Now, what about the Brownian motion or the Brownian movement? The Brownian movement arises due to the impact of the molecules, yes, of the dispersion medium. Let me abbreviate dispersion medium as DM, yes, with the colloidal particles, yes, with the colloidal particles. Okay. So what I mean by impact, it's the collision, of course, yes. So the collision which occurs, yeah, and in that case, it would always be more pronounced for smaller particles. Okay, there's a reason behind this, of course. Let me just complete this statement. Okay. Now, why smaller particles? Because or otherwise I would say lesser the size of the particles, more would be the speed gained by them. Yes. So in short, we can say that the speed of the moving particles, yes, the speed of the moving particles will be inversely proportional to the size of the particles. Yes. So in short, it indicates smaller the size, more would be the speed, and hence Brownian motion would be more pronounced for smaller particles. That would be our correct statement, right? So I would say option number 2 is absolutely correct. Now let us analyze the other statements. The third statement says that, let me put it up over here, that one would expect charcoal to absorb chlorine more than hydrogen sulfide. Now, this is absolutely incorrect. Okay. In fact, charcoal would absorb hydrogen. Oh, sorry, I misspelled the absorb word. Yeah. So it would absorb hydrogen sulfide to a larger extent. Okay, as compared to chlorine. Now, why is it so? Because hydrogen sulfide tends to be an easily liquefiable gas. Yes, what is it? Easily liquefiable gas as compared to chlorine. Yes, and whenever we talk about an easily liquefiable gas, these gases would be readily absorbed. Yes. Now, the reason behind this is they are having a higher critical temperature, okay, which is indicated as Tc, as well as they have strong van der Waals forces of attraction. What is it? Strong van der Waals forces of attraction, due to which they bind well, and hence absorption is going to be more. Yeah. So again, I would say that the third statement also went in as an incorrect option. Okay. Now what about the fourth one? The fourth one says that the Hardy-Schulze law states that bigger the size of the ion, greater is its coagulating power. Now, first of all, what is this Hardy-Schulze law? I hope you remember it. Yes. So that was from the surface chemistry part, the colloidal chemistry, I would say, to be very specific. The Hardy-Schulze law, or the rule, gives us an idea of the amount of the electrolyte which would be required to coagulate a colloidal solution. Okay, so there are many factors upon which this coagulation depends. Yes. So for instance, we can say that if at all we were considering the charge, the valency part, yes. So we would always say that greater the valency, more would be the coagulation. Okay. So similarly, in that case, we can say that smaller the size, more would be the coagulation. Yes. Or otherwise, if at all we want to talk about the bigger factors, yes, more will be the coagulation. Yes. So bigger factors means we would be speaking about the bigger charge. Yes. The greater valency. Okay. So that would definitely bring in more coagulation. So again, the fourth statement is also incorrect. So we have only one statement which is correct, and that is about the Brownian movement, which is reflecting in option number 2. I hope you understood the explanation. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.